Hey everyone, so today in this video we're going to be solving Leetcode 4006, which is count valid prefixes. So essentially you're given a binary string s, and a prefix of s is considered valid if its characters can be rearranged to a form of alternating string. And we need to return the number of valid prefixes of s. So we know a binary string consists of zeros and ones. A prefix of a string is a substring that starts from the beginning of the string and ends to any point within it. And a substring is a contiguous non-empty sequence of characters within a string. And a string is considered alternating if no two adjacent characters are equal. So there's clearly some key information you need to know here. You need to understand what prefixes are, what substrings are. And once you do know those two things, the key bits of information for this problem are of the following. So a prefix of s is considered valid if its characters can be rearranged to form an alternating string. And an alternating string is a string that has two adjacent characters no two adjacent characters are equal. So if we look at a simple example where we have the string s is equal to 0, this is invalid. And the reason being is that there's two characters next to each other which are equal. So this is invalid. If we look at this string is valid. And the reason being, the characters that are next to each other are not equal to each other. So this is valid. Let's have a look at the first test case. So let's look at the prefix at index 0. At index 0, our prefix is just 0. Sorry, our string is 0. Now, this is valid because there's nothing next to 0. So it has to be valid. If we think about it, there's nothing next to the 0 on this side, there's nothing next to 0 on this side. So by definition of how we've defined it being alternating, this is valid. Let's look at P1. So P1 is invalid because the zeros in the example we just did that are next to each other are equal. So this has to be invalid. Let's look at P2. P2 is valid. And the reason being, we can actually rearrange P2 such that we have this 0, 1, 0. This now means that we've placed the 1 in between the two zeros, so they're now not next to each other, so this is valid. Next, P3. P3 is invalid, and you can deduce that by looking at the fact that there's no way you can move this 1 such that no two zeros are next to each other. So this is invalid. And you can test that yourself. And for P4, P4 is valid because what you can do is we can rearrange the ones so that the zeros are not touching each other anymore. So we'll get the following. We'll have 0, 1, 0, 1, 0, which is valid. So if we count the total number of prefixes that were valid, we had one at 0, we had one at 2, and we had one at 4. So this is 3 in total. So the answer we'd return here is 3, as given in the example. Let's look at a different example, the other test case. So if we look here, P0 is 1. As we mentioned before, there's nothing next to the 1 on either side. Therefore, this is valid. Similarly, if we look at P1, there is nothing, the two elements next to each other are not equal. So this is valid, they're alternating. And then lastly, P2, these three, if you look at 1, at index 0, there's nothing next to it on the left, and then the 0 next to it is not, it's not 1, so this is definitely valid. And for all combinations, if you look, there's no way that there's two adjacent elements touching each other. So this is valid. Therefore, what we'd return is we would return 3. One observation you can make is we don't necessarily need to keep track of the position. But what we could do is we could actually track the number of occurrences of how many zeros and how many ones there are. And that could give us some interesting information. So if we just keep a track of all the zeros and ones, in P0, there's only one 0. and there's no zeros. And remember, this was valid. This was valid. Here, there are 2 zeros and there are 0 ones. So, and remember, this was invalid. Here we have 2 zeros and we have 1 1, and this was valid. Here we have 3 zeros and we have 1 1, which is valid. And lastly, we have 3 zeros and 2 1s, and this was also valid. Oh, oops, I meant to say this was invalid. Just rub that out. This was invalid. Now, if there's one observation you can make here, is that the ones where they were valid, so for example, number of zeros, number of ones, this was valid because there was nothing next to the 0. This was invalid because the 2 zeros had no 1 to kind of block or be placed in between them. P2 was valid because we had 2 zeros, but we could place a 1 in between them. 3 was invalid because we had 3 zeros and we could place 1 0 in between them, but then the other 2 zeros would be next to each other. So this was invalid. And then when we had 3 zeros and then 2 1s, it followed that we could place the 1 in between the 2 zeros here, and we could place the 1 in between the 2 zeros that would form here, and we would get a valid sequence. And similarly, we can do the same here. Number of zeros, the 0 zeros here, but there's 1 1 here. There is 1 0 here and 1 1. This was valid. This was valid. And lastly, there's 2 1s here and 1 0 here. This was also valid. And you'll notice a pattern here. And there's a key observation that we can make. We can say that if the difference between the number of zeros and the number of ones is 1, or if they're equal, that is the absolute difference between zeros and ones is equal to 1, or the zeros are equal to ones, we can express this as the number of zeros minus the number of ones, the absolute difference, is less than or equal to 1. And now with this information, we can write our solution. So if we write our solution, we want to return the number of valid. So let's say valid. Initially, there's only 0 valid elements. What we can now do is we can initialize our count of 0 and count of ones, which is they're initially going to be 0 and 0. What we can do is now loop between each character in S. And if my character is equal to 0, then we can do the character, count 0 plus equal 1. Otherwise, we know it's a 1, so it's going to be C, count 1, count ones plus equal 1. And now we need to check if it was valid. So we need to check, if we go back to our condition, is the number of zeros minus ones is less than or equal to 1, then it is valid. And then we can increment valid by 1. So if the absolute difference between count 0 minus count 1 is less than or equal to 1, we increment valid plus equals 1, and now we can return valid, and that is our solution. Assuming I haven't made any mistakes, yep. And if I click submit, that should be answered. And that is the solution to Leetcode 4006. Thanks for watching.